7.G.3 is about 3D slices, which we also call cross sections. They're like taking a slice or a two-dimensional piece out of a three-dimensional figure and seeing what that is. So starting on number 1, select all faces of the right rectangular prism that have the same shape and dimensions as the cross section indicated. So here's the cross section here. So what all looks the same? Well, this front face and this back face. Number 4, a cross section of a cone is made perpendicular to the base and through the vertex as shown. So we have this cross section is what it's describing, and we see that that is a triangle that goes through a cone. The cone has a base diameter of 5 meters, so this distance across is 5, and a height of 9 meters. Complete the sentence to describe the shape and dimensions of the cross section. So it is a triangle with a base of 5 and a height of 9, and these are in meters. Standard G4 is about circles. We can find the circumference and we can find area, and we have these formulas on your reference sheet. So we're going to start with problem number 2. What is the circumference in centimeters of the circle? Notice what it gives us. It gives us this distance all the way across the circle, which is the diameter. So I'm going to use the formula C equal pi d. I get this off my reference sheet. It says use 3.14 for pi. We'll multiply that by 18 and get 56.52. So 56.52 centimeters, which, by the way, is just the distance around the circle. Number 4, what is the diameter of a circle with a circumference of 37.68 inches? Use 3.14 for pi. So I'm going to use the formula for circumference of a circle, C equal pi d. It gives me circumference is 37.68. It says use 3.14 for pi, and we're looking for d, the diameter. So we've plugged into our formula. I'm going to divide both sides by 3.14 to get d by itself, and I get 12. So the diameter is 12 inches. Number 5, what is the difference between the area of the larger circle and the area of the smaller circle? Leave your answer in terms of pi. So we see the difference between them. That indicates we're going to find the area of each and then subtract. So for the larger circle, we know the area is pi r squared. And for this larger circle, we have a radius, which is 8 plus 1, which is 9, and that's the radius. So the area is equal to pi times 9 squared, which is 81 pi, and that is meters squared. For the smaller circle, we do the same formula, A equal pi r squared, but for this one, the radius is 8, so pi times 8 squared, which is 64 pi meters squared. And then to find the difference, we simply subtract. 81 pi minus 64 pi equal 17 pi, and we do know that's in meters squared. Answer choice A. Number 9, the area of a circle is 113.04 square meters. What is its diameter? Use 3.14 for pi. So we're given the area, we're asked to find the diameter. We don't have an area formula that uses diameter. Our area of a circle formula uses radius, so we have A equal pi r squared. But if we can find the radius, then we can double that to get the diameter. So the area is 113.04. It says use 3.14 for pi, and we're looking for r. So I'm going to divide both sides by 3.14. So r squared is equal to 36. And now I want to get r by itself. So I'm thinking, what times itself is 36? Or I could actually take the square root of both sides and say, well, r is equal to the square root of 36, which is 6. So this is r. Now I need to find the diameter, which is equal to twice the radius. So the diameter is equal to 2 times 6, which is 12, and this is measured in meters. Answer choice B. Standard G6 is about area, surface area, and volume. This standard really focuses heavily on using formulas to find different size figures, different dimensions. Number 3, what is the area of the figure shown? So one thing I noticed very quickly is this is a composite figure. It's made up of this triangle, and it's made up of this rectangle. So I'm going to find the area of each and then add them together. So I'm going to start with the area of the triangle. That area is 1/2 base times height. And the base and the height have to meet at 90 degrees. And one of them must be one of the sides of the triangle. So if I look at this side, this base, it's made of 3 plus 5, which is 8. And the height is 2. So I've got 8 times 2. So half of 8 is 4 times 2 is 8. So the area of the triangle is 8 square inches. Now to get the area of the rectangle area is equal to the base times the height, or we could use length times width. We just said the base is 8. The height is 2.5. So 8 times 2.5 is 20. And so the composite area, the total is just adding all the areas together, which is 8 plus 20, which is 28. So our answer is 28 square inches. And area is always measured in units squared. Number 4, what is the volume of the rectangular prism in cubic centimeters? So we're finding volume. We know that this is a rectangular prism. I'm going to start by finding the area of the rectangle. Now, this could be done different ways. You may know a formula for volume, length times width times height for rectangular prism, and that's true. You could use that. But I'm going to start by just getting the base area because I can do this for any kind of prism other than rectangular prisms as well. So the area is base times height. So I'm going to use 4 times 3, which is 12. Now I want to find the volume of the whole rectangular prism. And volume of any prism is V equal capital B for base area times the height. We just found the capital B base area was 12. And the height is this distance between the two bases. There's a base at the one end and a base at the other end of a prism. And so this height is 9. And 12 times 9 is 108. So we get 108 cubic centimeters because volume is measured in cubic units. Okay, number 5, a rectangular prism is 9 meters wide, 5 meters in length, and 6 meters in height. What is the surface area of the prism? So when I'm finding surface area, I'm actually finding all of the faces of this prism, finding all the areas. In this case, there's 6, and we're going to add them together. So let's start with the top and bottom. That would be these faces. The top and the bottom would be areas equal to base times height. So we have 9 by 5, which is 45. So there's 2 of those. Next, I'm going to get the, let's say the left side and the right side, the faces. So left and right. area equals base times height. We have 6 by 5, which is 30. And then let's go ahead and get the front and the back. Okay? So front and back, area equal base times height. These are 6 by 9. And notice that you multiplied a different pair of numbers every time. 6 times 9 is 54. So now to get the surface area, that's the total, we're going to take the top and bottom. There were 45 for each, and there were 2 of those. And then the left and right, there were 2 of those that were 30 units each, square units. And then we have the front and back. There were 2 of those that were 54 square units each. And we just go through and simplify that, and we'll get 258. And this is area, so it's square meters.